Everyone, welcome back to Logic Binder. In this video, we shall discuss how to convert regular expression to finite automata. Here, the regular expression can be converted to NFA with epsilon moves and then to NFA without epsilon moves and next to DFA. Again, DFA can also be converted to regular expression. This forms a cycle. Okay. In flat, we have seen these conversions. In this subject compiler design, we don't need all these conversions. We are going to see a topic called generation of minimized DFA based pattern matches, which will be discussed in next video. As of now, we will discuss how to convert regular expression to NFA with epsilon move. Now let us see conversion of regular expression to finite automata. There are some basic rules. The first rule is, suppose if the regular expression is pi, means the language is containing no string, then the NFA will be like this. An initial state, you can take a final state, and no transition from this state to this state or this state to this state. This is the NFA for regular expression pi. Next, if R is empty string, then simply you can take like this. Next, if regular expression is A, where the input alphabet is containing only A, means the language contains R is equal to A, means it is containing only the string A. Then the NFA is Q0 to Q1 on A. You can start with the initial state. You are moving on A to the final state, means you are reading the input A. Here only the input A is read. Next, R equal to A plus B, means sigma is containing both A and B, and the language is containing the string A and also B. If you are having these kind of things, means it is the language is containing A or B, means the initial state may go on A or B to the final state. Next, if R is A dot B, means the input symbols are A, comma B, and the language is containing the string A followed by B, means the only string AB. Now you can see the diagram. It is reading first A by moving from Q0 to Q1 followed by B. See here. After reading A and then B, it is reaching the final state. This is how we will design NFA for R equal to AB. Next one, R equal to A star, means the input alphabet is only A and the language is empty string A, AA, triple A, 4 A's, 5 A's, and so on. Let us take an initial state, and this will become the final state also on A. See, if you are directly coming to the final state, the string is epsilon. If you are moving one time, it is A. If you are moving two times, it is AA. If you are moving three times, it is triple A, like that. Next one, R equal to A star B. See, we need to combine these two. First, A star B. We shall draw a diagram for. See, A A star followed by B. This is A star followed by B. Here you are not taking here final state. If I take final state here, you will end in A, but the string must be ending in B. That's why I have taken the final state here. Here the sigma is AB and the strings are, see, epsilon B means B, AB means AB, double AB, triple AB. You can see here. Okay, I'm starting with the initial state and not moving through A. Directly I am moving through B, then I will get B. If I am moving through 1A and then B, it is AB. 2 times A, 1B, it is AAB. Like this it will take. Next one, R equal to A star B star. For A star we shall draw and then followed by B star. Okay. Here you can have epsilon. See what are the symbols we are using? AB. See the language. It is, if you consider A star, it is sigma A means sigma B star, means it will include sigma A comma B, B, a combination of all the things. It can be B, A. Sorry, it will start with B only, A only. Now you can see here. Let us see whether this string is accepted or not. See, if I start with the initial state, it will go 2 times. And then epsilon move, it will reach the final state. Let us see AB. It will start here, 1 move A, followed by epsilon, followed by B. Like this, any number of A's followed by any number of B's. Next, R equal to A plus B whole star. Means input is AB. Can you guess this? See, the strings will be, as you are having star, it is simply this combination of A and B. It can be A, B, A, B, B, A, B, B, A, triple B, B, A, B, B, anything. See the diagram? Simply Q0 is the initial state and it is also the final state. It is moving to itself on A or B. These are the basic diagrams for converting finite automata to regular expression. Based on these, we shall see some of the examples how to convert regular expression to finite automata. Now let us see some examples. R equal to A star B followed by A plus B whole star. For A star, as we know, it is a self loop on A. Okay, and then it is followed by B, and then it is followed by A plus B whole star. What is the diagram for A plus B whole star? This is the diagram, right? We are going to take it here. Simple. This is the diagram for this regular expression. Next one, R equal to A plus B dot C. First we shall draw for A plus B. As we know, A plus B is A or B. We are not going to end here. We are having following by C. And then here we will end. See here what you will get. It is AC plus BC. Means the language is containing AC comma BC. Only these two strings. You can see here. When you start from the initial state, you can go this way or this way. If you go this way, it is AC. If you go this way, it is BC. Only two strings are accepted by this NFA. Next, R equal to 0 star 1 plus 1 0. First we shall draw for this plus like this. 0 star 1, it is ending in Q1. This side it is 1 0. Now we shall extend the diagram. See, we shall draw for 0 star 1. What is that? 0 and then followed by 1. It is ending in Q1. This side what you are having? 1 followed by, you can take some other new state and followed by 0. 0 star 1 or 1 0. Okay. This is about finite automata and conversion of regular expression to finite automata. Thank you.